Okay guys, today we're going to start with 8.1 ratio proportion. Again, and a lot of you guys have been taking advantage of this. If you have any questions, definitely get to me via email. I've been able to answer a lot of your questions, and I think it's really worked out well. First we're going to go over with ratio proportion, we're going to go over how it relates eventually to different figures. First we're going to look at our warm-up here. We're just going to reduce some fractions. We look at 12 over 15, and the number that's going to be on both of them is going to be 3. 3 goes into 12 4 times, and it goes into 15 5 times. Okay, 14 over 56 is just going to reduce down to 1 over 4. Okay, and then we have 21 over 6. The common number goes into both of that. The common factor goes into both of that is going to be 3. 3 goes into 6 2 times, and 3 goes in to 21 7 times. Little trick right here with 90 over 450, a bigger number. But if we see a 0 on the end, we can initially just cancel that out. Now instead of looking at 90 over 450, we're looking at 9 over 45. And of course we know 9 goes into 45 5 times, so this is going to reduce down to 1 over 5. Okay? So just a quick refresher on reducing some fractions on our warm-up. As we move down here, a couple definitions. Ratio is just going to be a comparison of two quantities written in the same units, and you're going to see how when we get to some of these problems, you're going to reduce everything to the smaller unit of measurements. A lot easier way to do that. You avoid having some decimals. And these are the different forms you're going to see. You could see in the word form 3 to the 2 would be an example. In the colon form, same thing, 3 to 2. And then, of course, in the fraction form, 3 to 2. But they all really mean the same thing. Okay? And again, this is a review of some things you've already done. Okay, now we're going to look at simplifying the ratios. When we simplify the ratios, the most important thing we have to realize here is we've got to deal with the same unit of measurement. Okay, and if we have that, we're just reducing the fractions. If we look at 6 over 30, they're both in pounds, so we're looking at just reducing 6 over 30. We all know 6 goes into 6 once, it goes into 35 times. So that's going to be 1 to 5, 1 over 5 as a fraction. Now, here with 12 centimeters over 4 meters, the common mistake here is just to make that 4, or I'm sorry, make it 3 over 1. But in this situation, you're dealing with centimeters and meters. You've got to change the meters to centimeters. So 4 meters, there's 100 centimeters in each meter, so 4 meters is going to be 400 centimeters. And that's going to go on the bottom. Okay. Then we would reduce that. We know that 4 goes into 12 3 times, and 4 goes into 400 100 times. There's some visitors along here. So that would be your reduction. And then you could just put it, again, centimeters to centimeters. Okay. Now, we look at our next one. We have 6 feet over 18 inches. Again, you've got to have the same unit of measurement. And we want to go with the smaller unit of measurement. So we want to put everything, the smaller unit of measurement is inches, so we want to put everything in inches. So we know there's 12 inches in 1 foot. So we're going to do 6 times 12, or 72 inches. Converting feet to inches, over 18 inches. And this is going to reduce down to 4 to 1, because we all know 18 goes into 72 4 times, so this is going to be 4 to 1. And you can put the unit of measurement right there. Okay, so that's what we're dealing with when we're simplifying the ratios. Okay, the first problem we're going to look at that's going to relate to an actual figure is going to be a rectangle. And they're talking about the rectangle A, B, C, D. Again, always draw your figure. Makes life a lot easier. You can see everything in front of you. And we're going to have this be A, B, C, D. Okay, let's look at the problem. The perimeter of the rectangle A, B, C, D is 60 centimeters. Okay, so remember, just to review, the perimeter is the distance around. The ratio of AB to BC is going to be 3 to 2. Okay, they want you to find the length and the width of the rectangle. So when they say the ratio is 3 to 2, the bigger number, 3, would be the length, and the 2 would be the width. Okay, that's the ratio. What we want to do here is put our x next to it, our unknown. Okay, our unknown there. Okay, because we know the ratio is 3 to 2, but we don't know exactly what the number is going to be. All right, and again, they're talking about perimeter. So, you know, to find perimeter, it's going to equal 2 times the length plus 2 times the width, or you could just add everything up, okay? Add everything up. Here, you know, this is 2x because opposite sides of the rectangle are going to be congruent, as well as 3x down here. So we could do 2 times the length plus 2 times the width, or we could just add everything together, okay? 3 plus 2x. 3x plus 2x plus 3x plus 2x, and we know the perimeter is going to equal 60. Now we're just solving, once we set this up, we're just solving this algebraic equation. And we combine our like terms, and we're going to get 10x equals 60. And 10x equals 60. We divide through by 10. We're going to get x equal to 6. Okay? Now, I always say we have to go back and make sure that we put the answer that they're asking for. They didn't just ask for x, they wanted you to find the length and the width. So we look at the length, AB, that's going to be 3x. And that's going to be 18. And BC is going to equal 2x, 2 times 6, and that's going to be 12. Okay, we just put our x in there, our value of our x in there. Okay. And we should also put centimeters here. All right, so that's how we're going to solve a figure like that. When they give you the ratio, this is how you're going to set everything up. Okay. Okay. Next thing we're going to look at is the measures of the angles in a triangle. Okay. In the particular triangle that we're talking about here, it's going to be in the ratio of 1 to 2 to 3. So we could just draw any triangle. And it'll be in the ratio of 1 to 2 to 3. 1x to 2x to 3x. Okay? So that's how we're going to basically label everything in the triangle. And if we do this, we're going to end up having all 3 angles. Of course, we know all 3 angles of a triangle add up to 180 degrees. So all we're going to do here is we're going to add 1x plus 2x plus 3x, and that's going to equal 180 degrees. Combine like terms, we're going to get 6x equals 180, and x is going to equal 30 degrees. Now again, make sure you go back to your original question. They didn't just ask you to find x, they asked you to find each angle of the triangle. Okay? So if you look at your values here, 1x per x is going to be 30 degrees. Okay? 2x, obviously, is going to be 2 times 30, or 60 degrees. and then 3x, 3 times 30, degrees. And again, we're substituting in 30 for x. Okay, so that's what we're talking about when we have a triangle here. Again, always draw the figures, put everything in there. Try not to do it in your head because you're more likely to make a mistake. And double check, make sure you're answering what they're asking you up to the original question. Now, when we look at a proportion, that's going to be an equation that equates two ratios. Again, this is a review. It's something you guys have done before, and I always like to cross multiply. All right? We know if we cross multiply, and we have a proportion that if you cross multiply, those values are going to be equal to each other. A great way to find, say, a missing x. All right? So we're going to move this up and look at a couple problems. Okay, the first one that we have here, if we look at 4 over x equals 5 over 7, again, you would just multiply the 4 times the 7, 28, and the 5 times the x. So the 5x equals 28. Most of the ones I'm going to give you, you won't have a decimal answer like you do in this one. So we're going to divide through by 5, divide through by 5, and we're going to end up getting roughly 5 and some change. I'm going to estimate, say, 5.6 roughly there, or thereabouts. And that's going to be the answer. Okay, we get this by cross multiplying. Now, sometimes people multiply and say just divide the top number, try to come up with shortcuts. I would guard against you doing that. I'd probably not want you to do that because you're running into situations here where you have an expression, it's a binomial here, and we have to make sure with this we put parentheses around it. We have to distribute when we cross multiply. So in this situation, you're going to end up getting 2 times y plus 2 equals 3y. Okay, so you don't want to just multiply the 2 times the y and forget about the 2 here. All right, so we've got to have 2 times the y, and then 2 times the 2. When we distribute that, we're going to get 2y plus 4 equals 3y. All right, then we just subtract our 2y, subtract our 2y, and we're going to get 4 equals y. All right, but I can't stress enough that when you see a binomial here, that you're going to end up putting parentheses around that. You want to do that right away so you don't make the mistake of just multiplying the 2 by the y and forgetting about the 2. And we're going to get y equal to 4 in this situation. Okay? And if you end up putting the y in here, 4 plus 2 is 6. 3 over 6 would be 1/2. And then 2 over y, 4, is also 1/2. So the nice thing about this is you can go back and check your answers. So that's it. You know, just a quick recap of ratio and proportion. Again, something you guys have seen before. The only thing that's a little bit new is when we put the figures in there and look for the perimeter and then of the rectangle and look for the different angles in a triangle. Like I said, I can't stress enough, if you have any questions, definitely reach me via email, and we'll be able to hopefully get things squared away. And I will see you guys for the next lesson.